Hi everyone, myself Dr. T. Siva Nageswara Rao, working as Assistant Professor of Mathematics in the Department of Mathematics and Management Science. Today I am going to discuss about subject name is matrices and calculus. In Unit 2 I am going to explain eigenvalues and eigenvectors. Now in this unit I am going to explain the following contents. First one is eigenvalues and eigenvectors, diagonalization of the matrices, Cayley-Hamilton theorem. Applications of Cayley-Hamilton theorem is finding inverse and power of the matrices, and last one is the properties of eigenvalues and eigenvectors. First I will explain what is the definition of eigenvalue. If you want to talk about eigenvalue, it is mandatory that the given matrix should be a square matrix. So we are taking, let capital A be a matrix of order n by n. Here we will construct a matrix is of the form A minus lambda I, where lambda is a real number or complex number and I is the identity matrix. The order of the identity matrix is depending upon order of the given matrix capital A. If it is 2 by 2, we will write I is equal to 1 0 0 1. If it is capital A is of order 3 by 3, we will write I as 1 0 0 0 1 0 0 0 1. So here we will construct a characteristic matrix is of the form A minus lambda I. By finding the determinant of A minus lambda I, we will get the characteristic polynomial. By equating this characteristic polynomial to 0, we will get the characteristic roots. The characteristics roots are also called eigenvalues or are proper values. This is about eigenvalues. Now we will see about the definition of eigenvector. If you want to talk about eigenvector, first of all it is mandatory to find out what are the eigenvalues of the given matrix. So the definition is like this: if lambda is an eigenvalue of capital A, then there exists a non-zero vector capital X such that Ax is equal to lambda x. Here the non-zero vector capital X is said to be eigenvector corresponding to the lambda of capital A. Now we will see one example how to construct the characteristic matrix, how to find the determinant of the characteristic matrix. From this we will get the characteristic polynomial. After equating this characteristic polynomial to 0, we will get the eigenvalues. Let us take one small example. Capital A is equal to the given matrix 1 0 0 0 1 0, 0 minus 1 2 2 0 0. Here we will construct the characteristic matrix. How to construct the characteristic matrix? The form is A minus lambda I. Now here A minus lambda I, substitute in place of A with the given matrix, minus lambda is a scalar, it may be either real or complex. Here we are taking identity matrix. This is what I said previously, the given matrix of order 3 by 3, so we will take 3 by 3 identity matrix. Now what is 3 by 3 identity matrix? 1 0 0 0 1 0 0 0 1. Now by simplifying this expression, we will get A minus lambda I as first row 1 minus lambda 0 0 0 minus 1 lambda 2 2 0 0 minus lambda. We will call it as this matrix as characteristic matrix. Now our aim is to find the characteristic polynomial. Just by finding determinant of the characteristic matrix, we will get the characteristic polynomial. Now find out the determinant of the characteristic matrix. Now this is determinant of the characteristic matrix. Here we will write this as 1 minus lambda multiplied by minus 1 minus lambda minus lambda. Now I will simplify this. That is, from this take out minus as common, I will get minus 1 minus lambda into 1 plus lambda multiplied by minus lambda. From this I will write minus into minus plus lambda into, this is 1 minus lambda into 1 plus lambda gives 1 minus lambda square. So we will call this as the characteristic polynomial. Now the characteristic equation. By equating this characteristic polynomial to 0, we will get the characteristic equation. Now we are going to find the roots of the quadratic equation. Sorry, yes, cubic equation. Now what are the roots? Lambda is equal to 0, comma, lambda is equal to plus or minus 1. Now here lambda equal to 0 and lambda is equal to plus or minus 1. Lambda is equal to plus or minus 1. We will call it as the eigenvalues. So this is the process how to find characteristic matrix, how to write the characteristic polynomial. From the characteristic polynomial equating to 0, you will get the characteristic equation. From the characteristic equation, we will get the characteristic roots. The characteristic roots are also called eigenvalues or are proper values. Now here I am going to explain from the given matrix how to find eigenvalues and eigenvectors. Given that capital A is equal to 2, 2, 0, 2, 5, 0, 0, 0, 3. Clearly this is a square matrix of order 3 by 3. Now I am going to find the characteristic equation. What is the definition of characteristic equation we discussed earlier? The determinant of the characteristic matrix equal to 0 is called characteristic equation. So I am going to take the determinant of A minus lambda I is equal to 0. This implies determinant of 2 minus lambda 2 0 2 5 minus lambda 0 0 0 3 minus lambda equal to 0. That means I am taking here determinant of the characteristic matrix equal to 0. Now I will find out the determinant. This is equal to, this implies 2 minus lambda into 5 minus lambda into 3 minus lambda minus 2 into 2 multiplied by 3 minus lambda is equal to 0. This implies, now I am going to simplify this expression, 2 minus lambda into 15 minus 5 lambda minus 3 lambda plus lambda square minus 12 minus into minus plus 4 lambda is equal to 0. This implies 2 minus lambda into 15 minus 8 lambda plus lambda square minus 12 plus 4 lambda is equal to 0. Now I will multiply this quadratic polynomial with this linear polynomial, that is 2 multiplied with the whole quadratic polynomial, that is 30, 2 15s are 30 minus 2 8s are 16 lambda plus 2 lambda square. Now again I will multiply this quadratic polynomial with the minus lambda, that is minus 15 lambda plus 8 lambda square minus lambda cube minus 12 plus 4 lambda is equal to 0. Now I am going to simplify this. I will make it into order based on the highest degree minus lambda cube. Here 2 lambda square, 8 lambda square, totally 10 lambda square. 10 lambda square. Now lambda terms. Here minus 16 lambda, minus 15 lambda. Minus 16 lambda, minus 15 lambda. That is minus 31 lambda. Minus 31 lambda minus plus 4 lambda, which gives minus 27 lambda. So lambda terms are completed. Next we will see about the constant terms. Here 30 and this is minus 12, which gives plus 18 is equal to 0. So this is how we will find out the determinant of the characteristic matrix. Please keep it in your mind, my dear friends. Whenever you are calculating determinant of this characteristic matrix, please take care and write every step very carefully. If you are not concentrating on these steps, obviously you will get the wrong answer. So my sincere request to all of you is, please focus and apply more concentration whenever you are doing determinant of the characteristic matrix. Yes, now we are getting the characteristic equation minus lambda cube plus 10 lambda square minus 27 lambda plus 18 is equal to 0. Now our aim is to find the roots of this cubic equation. By substituting in place of lambda with 1, the LHS side is satisfied. So here we can write lambda is equal to 1. Lambda is equal to 1 is the root of the above cubic equation. Together with this, if you are substituting 2 in place of lambda, unfortunately it is not satisfied with lambda is equal to 2. So I will go for lambda is equal to 3. If you are taking lambda is equal to 3, then the cubic equation will be satisfied. Next, another root is 6. See, previously we substituted in place of lambda is equal to 1. Hence it is satisfied by the cubic equation. By using synthetic method, we can able to find out the remaining 2 roots. Otherwise, we can use the calculator for finding roots of this cubic equation. Now, from here onwards, I am going to explain how to find the eigenvectors corresponding to these 3 eigenvalues. Now, first one corresponding to first lambda, lambda 1 is equal to 1. How to find out the eigenvector? Previously, we studied about the definition of eigenvector. If lambda is an eigenvalue of the square matrix capital A, then there exists a non-zero vector capital X such that Ax is equal to lambda x, where x is called the eigenvector corresponding to the lambda. So, I will use the definition A multiplied with x1 is equal to lambda 1 multiplied with x1. Here what is x1 represents the eigenvector corresponding to the first eigenvalue. From this I will write directly A minus lambda I multiplied with x1 is equal to 0. Lambda 1 here. Now here I will write A minus lambda 1 I. That is, what is the given matrix? 2 minus lambda 1, 2, 0. 2, 5 minus lambda 1, 0. 0, 0, 3 minus lambda 1. This matrix multiplied by, I am going to take my vector capital X1 as column vector x1, x2, x3. On right hand side, this is 0 matrix, 0, 0, 0. Now I am going to substitute in place of lambda 1 with the first eigenvalue 1. Therefore, the resultant matrix is 1, that is 2 minus 1. Here it is 2, 0, 2, 4, 5 minus 1 is 4, 0, 0, 0, 3 minus 1 is 2. Multiplied with x1, x2, x3. This is equal to 0, 0, 0. Now here, this seems to be Ax is equal to 0, means homogeneous linear system of equations. In first unit already we are all familiar with how to find either trivial solution or non-trivial solution of homogeneous linear system of equations. If the rank of the coefficient matrix is equal to number of unknown variables, then the system will have only trivial solution, means zero solution. If rank is less than the number of unknowns, then we will have infinitely many solutions. In that case, we will introduce n minus r number of arbitrary constants. So I am going to find the rank of the coefficient matrix 1, 2, 0, 2, 4, 0, 0, 0, 2 for this homogeneous linear system of equations by using row transformations. What is my first row transformation? I want to use first row first column element to make second row first column element as 0. That is R2 goes to R2 minus 2R1. So from this 1, 2, 0, this is 0, R2, 4 minus 2R1. This is 0 and this one is 0. Third row 0, 0, 2 multiplied by x1, x2, x3 is equal to 0, 0, 0. Anyway, we will write this 0 row as last row. Hence, this becomes 1, 2, 0, 0, 0, 2, 0, 0, 0 multiplied by x1, x2, x3. On right hand side 0, 0, 0. Right. Clearly, this matrix is in echelon form. What is the rank of this matrix? In view of a matrix is in echelon form, the number of non-zero rows are said to be rank of the matrix. Hence here the number of non-zero rows are 2, therefore its rank is 2. Clearly, the rank is less than the number of unknown variables 3. Hence we will introduce n minus r number of arbitrary constants. So here we will introduce only one arbitrary constant. From this matrix form, we will write the system x1 plus 2x2 is equal to 0, x3, 2x3 is equal to 0. From this what you will get? x1 is equal to minus 2x2 and x3 is 0. I will introduce my arbitrary constant k to x2. Therefore, let us take x2 is equal to k. Hence, x1 becomes minus 2k. Therefore, the first eigenvector corresponding to the first eigenvalue lambda 1 is equal to 1 is given by minus 2k, that is x1 value, x2 value k, x3 value 0, where k is arbitrary constant which is not equal to 0. So this is how we are going to find the eigenvectors corresponding to each eigenvalue. So we are going to find two more eigenvectors corresponding to the eigenvalues, that is corresponding to lambda 2 is equal to 3. Now I am going to write ax2 is equal to lambda 2x2 implies A minus lambda 2I multiplied with x2 is equal to 0. Now I am going to write the characteristic matrix, that is A minus lambda 2I, that is 2 minus lambda 2, 2, 0, 2, 5 minus lambda 2, 0, 0, 0, 3 minus lambda 2 multiplied with, I am going to assume the column vector x2 as x1, x2, x3, 0, 0, 0. Now substitute lambda 2 as 3 here, minus 1, 2, 0, 2, 2, 0, 0, 0, 0, x1, x2, x3. Here, if you are observing this matrix system, the coefficient of x1, x2, x3 is minus 1, 2, 0, 2, 2, 0, 0, 0, 3. By observing last row, all the elements are zeros. Here, the matrix is not in echelon form. Our aim is to convert it into echelon form by using row transformations. Again, R2 goes to R2 plus 2R1. Hence, the resultant matrix is minus 1, 2, 0, 0, R2 plus 2R1. Again, it becomes R2 plus 2R1. It becomes 6, 6, 0, 0, 0, 0. Now, the matrix came into echelon form. Its rank is 2. The number of unknowns are 3. Hence, we will introduce only one arbitrary constant. From this system, we will write, from this matrix system, we will write system of equations. Minus x1 plus 2x2 is equal to 0. Right. 6x2 is equal to 0. From this, you will get x1 equal to 0 and x2 is equal to 0. Now, the rank is 2, unknowns are 3, we need to introduce only one arbitrary constant. To whom we will assign that arbitrary constant? Anyway, out of 3 unknown variables x1, x2, x3, we know what is x1 value, what is x2 value. We don't know what is x3 value, hence we will assign that arbitrary constant to x3. Therefore, the second eigenvector is 0, 0, k, where k is not equal to 0. This is the second eigenvector. Now we are going to find the eigenvector corresponding to third eigenvalue. Lambda 3 is equal to 6. Here, a into x3 is equal to lambda 3 into x3. From this, we will write a minus lambda 3I multiplied with x3 is equal to 0. Here, I will write the characteristic matrix. 2 minus lambda 3, 2, 0, 2, 5 minus lambda 3, 0, 0, 0, 3 minus lambda 3. Multiplied by, I am assuming the elements in the column vector like similar, x1, x2, x3. On right hand side, the column vector 0, 0, 0. Substitute lambda 3 here, you'll get minus 4, 2, 0, 2, minus 1, 0, 0, 0, minus 3. x1, x2, x3. Now, by using row transformations, our aim is to reduce this coefficient matrix into echelon form. Now, we are going to apply echelon form on this matrix. Transformation, R2 goes to 2R2 plus R1. Therefore, the resultant matrix is, this is 0. 2R2 means this is minus 2 plus 2, 0, 0. Third row, minus 3. Now, the matrix is not in echelon form, So we will interchange two rows. Then what is the resultant matrix system? -4, 2, 0, 0, 0, -3, 0, 0, 0. Now clearly the matrix is converted into echelon form. Now the rank is 2, number of unknowns are 3, therefore n minus r is equal to 1. We will introduce only one arbitrary constant. From this matrix system I am going to write system of equations -3 x3 is equal to 0. From this x3 value becomes 0 and x1 is equal to -1 by 2 x2. -1 by 2 x2. Therefore, we will assign arbitrary constant k to x2. Therefore, the third eigenvector is -1 by 2 k 0, where k is not equal to 0. So, my dear students, this is how we are going to find the characteristic matrix. Determinant of the characteristic matrix gives characteristic polynomial. The characteristic polynomial equating to 0 gives the characteristic equation. We will find the roots of the characteristic equation. We will call it as eigenvalues or our proper values. Corresponding to each eigenvalue, we calculated the eigenvector by using Ax is equal to lambda x. In next class, I am going to explain if a matrix have eigenvalues which are repeated. Here, what is the example I discussed? A matrix with distinct eigenvalues. Next class, I am going to explain a matrix with repeated eigenvalues. Corresponding to repeated eigenvalues, how to find the eigenvectors. Please practice the problems. These are the problems. Here I gave only one problem corresponding to distinct eigenvalues. Just practice this problem. Next class I am going to explain a matrix with repeated eigenvalues. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.